Hi guys, today we're gonna learn about graphing technique. Graphs are useful tools for organizing, displaying experimental data. Well, it can use that observe behavior when we subject another property of a substance to a control change. This graph can be categorized into few types. Increasing functions such as the condition shows. Decreasing function. This is slightly changed from increasing function. Next is constant function, where the function keep on remain constant. Another one is even function, where the y-axis become a mirror of the reflection line of the graph. Another one is odd function graph, where the 0, 0 become a mirror or a reflection point. Now guys, you have to remember these 6 graphs. First is linear function graph. Second is quadratic function graph. And the third one is cubic function graph, square root function graph, reciprocal function graph, and absolute value function graph, or known as modulus graph. And guys, you have to remember there is few graphic techniques that you need to learn and apply in this graph, as shown here. We'll discuss more in next slide. So first, let's start with linear function graph. Basically, it's a straight line. So guys, let's start with vertical shift, where y equals to fx plus c, where c is a constant. When the c is positive, it will shift upward. And it will shift downward if the c is less than 0, which is a negative. Next is horizontal shift, where the c is actually get touched with x. When c more than 0, it will shift to the right. When c less than 0, it will shift to the left. Next is compress and stretch. Whenever it is vertical compression or stretch, we have to remember that y equals to c dot f. While it is horizontal stretch or compress, then you have to remember that y equals to f cx, where the c get touched with x. That's why it's called horizontal. While this graph is vertically compressed and horizontal stretch, where c only between 0 and 1, such as 1/2, 1/4, and the graph will be compressed and stretched horizontally. While this is a bit different, where c needs more than 1 and it will horizontally compress and vertical stretch. While next is for reflection, where this is how it looks like when in reflection y-axis, and this is how it looks like when in reflection in x-axis. And next, let's go to quadratic function graph. Basically, it's the same concept, but the difference is only the shape of the graph. And the formula is fx equals to x squared. It still moves upward when c more than 0 and still move downward when c less than 0. Same with horizontal shift. It moves right when c more than 0, it moves left when c less than 0. While here, the graph looks wider if in vertical compression and horizontal stretch, and it is slimmer when in horizontal compression and vertical stretch. While in reflection of y-axis, this is how it looks like. In reflection x-axis, it is how it looks like. It is like an hourglass. So guys, now let's go to cubic function graph, where fx equals to x cubed, while x cubed plus c is still the same. It's still the same concept. It's moved upward when c more than 0, and it's moved downward when c less than 0. In horizontal shift, it's moved right when c more than 0, and it's moved left when c less than 0. Easy, right? It's the same concept again. While in this one, people usually get confused about it. This is how I remember it. Well, in horizontal stretch, you stretch a line and make it flat. When horizontal compress, you compress it until it looks so thin like this. While in reflection, either you reflect it in y-axis or x-axis, it's the same. The same. Now go to square root function graph, where fx equals to square root x. While in vertical shift and horizontal shift, it's still the same. Everything just repeat again. While in this part, just imagine you horizontally stretch the graph down, while another one, you just imagine you vertical stretch the graph up. While in reflection, it's like an eyebrow, okay? While in x-axis reflection, it's like this. Just remember it. Our next one is reciprocal function graph. It's still the same, just that with this, you have an asymptotic line. While in the reciprocal function, this is how it looks like when in vertical compress and horizontal stretch. While in this, it becomes much more wider. For reflection, it becomes like this. It's still the same. Just imagine that either you reflect it in x-axis or y-axis, it's still the same. Last but not least is our absolute value function graph, or known as modulus function graph, where fx equals to modulus x. In vertical shape and horizontal shape is still the same. In this condition, it becomes wider, while in this condition, it becomes slimmer. While in here, the reflection is still the same on y-axis, but however, in x-axis, it just flipped it over. Guys, that's all for today, and now it's questions time. Well, this is the questions. So this question is quite easy. Just analyze it and do it. So whatever is it, practice makes perfect. I hope you guys like the video and just enjoy it. Thanks for watching, guys. Brought to you by Group 2.